Hello students, so this question is from Instrumentation Gate 2018. It's a control system question. It's a very simple question based on phase margin. So find the phase margin of 3 by s plus 1 into s plus 2. So we know when we are finding the phase margin, first of all we have to find the frequency at which the gain becomes equal to 1. So if I consider g of s is equal to 3 divided by s plus 1 into s plus 2. Let us put s is equal to j omega. So g of j omega is equal to 3 by j omega plus 1 into j omega plus 2. So if you take the magnitude of it, this should be equal to 1 at the gain crossover frequency. Okay, so here the magnitude should be equal to 1. So 3 divided by square root of 1 plus omega square into 4 plus omega square. This is equal to 1, which implies that 9 is equal to 1 plus omega square plus 4 plus omega square is nothing but 4 plus 5 omega square plus omega power 4, which implies that omega power 4 plus 5 omega square minus 5 is equal to 0. So if I consider omega square is equal to x, then I'll have, it's a quadratic expression, x square plus 5x minus 5 is equal to 0. So the value of x will be equal to minus 5 plus or minus b square minus 4. It means 25 minus of minus 20 is going to be 45 divided by 2. So you'll get a positive and a negative value. So if it is a negative value, it is of no use for us. So the positive value that you're going to get here, okay, so x is nothing but omega square. You will get a positive value here. So ultimately the value of omega is equal to that of 0.924. This is nothing but a gain crossover frequency. So if you find the phase at this particular point, phase of, this is going to tan inverse of omega plus minus tan inverse of omega by 2. This is nothing but omega g. Okay, so if you substitute, okay, you will get the value which is equal to that of minus 67.53. So phase margin is equal to whatever angle you get here, for example 5, so 180 plus 5. So it is equal to 180 minus 67.53. So this is equal to that of 112.47 in terms of degrees. So the phase margin is equal to 112.47 degrees.